I would like to invite our next set of speakers for session 3. So first, can we have Mr. Palash Navroz Tarapur from Atmos Power Private Limited? He's the Director Business Development. Mr. Palash, ladies and gentlemen. Kindly have a seat. Next, we'll be having Mr. Marcello Barbato. He'll be joining us in some time. He's a business development professional from Prodival. And then next we have Mr. Florian. Can we have Mr. Florian with us? He's from Armatech and he's the head of sales. Next, can we have Dr. Alphonse? Dr. Alphonse, ladies and gentlemen. He's a consultant from Gas Processing Equipment Private Limited. Now, can we have Mr. Sunil KM with us on stage? He's the director of KIS Group. Mr. Sunil, ladies and gentlemen. Now, to moderate the session, can we have Director Arca Brains Tech Private Limited, Mr. Srinivas Kasula? Kindly come upon the stage. Now, Srinivas sir, I hand it over to you. Kindly take over.
Thank you, Mansha. So, yes, we are into the third session, and the session is a little bit difficult to handle after the lunch. So, just that's the reason we have kept it a panel discussion rather than PowerPoint presentation. And I just want to say that India is transitioning into energy transition. But when you see biogas, and when it comes to innovations, biogas and innovations comes hand in hand, and there are many new innovations which we are going to see in this session. And I'm sure that the experts or the esteemed speakers on the panel will throw some light on the equipments, technology, and the biogas projects or the biogas latest innovations which have been done. So without taking too much time, I would like our esteemed speakers to introduce themselves. Then we can directly start the session. Palash?
Hi, I'm Palash Navroz Tarapur. I'm the Business Development Director at Atmos Power Private Limited. We're into gas upgradation, purification, and dehydration. We work with various gases ranging from landfill gas, producer gas, synthetic gas, and most importantly, biogas. And we have our own patented technology for biogas upgradation, and we have installed about 125 plants across Asia using this technology. And I'll be happy to answer any questions that you guys may have regarding the technology or regarding how this technology can help your systems. Thank you.
Thank you. Florian?
Hello, my name is Florian Wück from Germany. I work for Armatech FTS. I'm the head of sales of the company, and we have a subsidiary in Hyderabad, Armatech India Private Limited, with our managing director Vichalanga Kumar. And we produce for the biogas plant the side entry mixers. And we have a really good opportunity here in India. We sell a lot of this mixer now for the biogas projects.
Yes. Dr. Alphonse?
Yeah, good afternoon. Thanks. Yes, I'm Alphonse Scholte. I'm working since more than 40 years in that business of gas processing, gas upgrading, and I was the co-founder and operating a company in Germany which dealing with gas processing since mid-80s, and yes, I was working till 2021, where I left, let's say, my own operation. I thought I get retired, but it was a little bit boring. So I got back to the business. And since then, I'm supporting companies, especially in India, gas processing equipment, for developing state-of-the-art gas processing plants. And especially here for this application, it's the biogas upgrading. And we are using technologies which we have developed the last 40 years in Germany. Thanks.
Yes. Sunil?
Hello. Yeah, good afternoon, everyone. I'm Sunil KM. I'm director at KIS Group. KIS Group is a world-renowned biogas company. We have world over 8 to 10 offices now operating overseas, including India. And we are the EPC and boat model project developers for the biogas, bio-CNG, and biogas power generation. Our projects are operating in India, Indonesia, Malaysia, Papua New Guinea, Africa, and even up to South America. That is our credibility. Thank you so much.
Thank you, Sunil. And I would like to add that if you see, I'm Srinivas Kasula. I represent our Brains Tech and have more than 20 years of experience in the field of biogas. So here, a few experts are there with whom I have spent quite a long time and in the industry. So we do give end-to-end biogas projects as well as laboratory digesters is what we represent. And if you see the panel right now, we have smallest lab digesters of 500 ml. Then comes the KIS group, which they have installed projects in India, abroad, based on different feedstock. We have PSA upgradation units where they have more than 120 already working installations. We have another group where they are looking for good projects where the innovations can be brought in and the leakages or the methane slippages can be brought in, down. Again, a membrane scrubber is there. Unfortunately, he couldn't join, but he is on the way, so he will join us. And let us see what makes it different. And Mr. Sunil, when I talk about your company no doubt is the forefront in the biogas technology. You name the feedstock and you are already touched that feedstock, whether it is cow dung, press mud, spent waste, chicken litter, or now you're also working on napier grass. So what innovations have you brought to the technology so that these innovations can be replicated by other technology suppliers as well? So could you please answer or throw some light on it?
Thank you, Srinivasi. So one of the, I would say, one of the good question. Before dwelling into the technological innovations, we are one of the first company to develop the biogas production joint venture basis. When we started marketing the biogas projects, the first questions came from the client. So, is it going to operate? What is guarantee? We said we stand guarantee. Yes, we use stand guarantee, but we need a commitment. So that is how we built our JV project way back in 2013 and 14. So in the first project started in Indonesia. That is how we started. That is our commitment, and that is the kind of revolution. So we started in the biogas industry. And coming back to the technologies innovations, I would say that biogas industry is on the cusp of many innovations. There is you name anything that can be integrated into the biogas technologies. The technological innovation, including the mechanical innovations, electrical innovations, the latest AI integrations. These are all adding value to the biogas and the bio-CNG sector. The latest innovation we have done in the pre-treatment process, the bio boosters. So bio boosters basically this is to disintegrated long fibers into the soluble fibers. So that is how we have been using this bio boosters, which is under, I would say, in trial basis. And another 2 to 3 months we should be having the a palm fiber based biogas plant running successfully, like a successful revelations. Then the coming to the purification processes, we have developed the scrubber system, which is basically on and off type of scrubber. So most of us are familiar with the a biological scrubber or biochemical scrubbers, which need to be run all around the clock to keep it running. Even though there is no biogas generation, to keep the bacteria alive, we have to keep the scrubber running. So the kind of scrubber we have developed is this is like a on and off. Whenever you have the biogas, you can switch on, other type, so you can switch on. Thus, this reduces your operation maintenance cost. Then coming to the VPSA and the purification system, we have done a set of new improvements in the VPSA systems, which is generating very good results. So achieving very good purity, so up to 99%. So that is kind of a satisfaction for us also. These are the few of innovations. Srinivas.
So as a EPC or a technology provider, you have touched almost every section of the biogas project, right from feedstock treatment, then your bio boosters. And I'm sure that after this session, many inquiries for bio boosters will come in.
Thank you so much.
And
Sure,
Florian,
sure.
when I talk about the agitators, so in the context of your equipment, how, or in the context of biogas production, how your equipments are you can ensure that the amount of biogas generation is more, efficiency is good, at the same time the feedstock feedstock requirement to the plant would be at minimum.
Yeah, now it's really important that you install in your biogas plant not the fast moving mixers, because the fast moving mixer for the feedstock in India, it's really hard to mix because of the high viscosity and the high dry matter content. And it's much more better to install a slow moving mixer like our Ammix Evo Plus with 96 RPM and 1.4 meter propeller. With this, we have a really good efficiency, and you can handle the really high dry matter content. And with the long fibers like Napier grass or paddy straw, in the past we changed now the older plants and the submersible mixer, around 70 pieces we put out, and we put our slow moving mixer inside. And for this is the best solution now for the biogas plants because of the efficiency and yeah, for the higher feedstocks.
Okay, so you mean to say that if I look at your equipment operational cost would be much lower compared to your competitors or other equipments in the market?
Yes, in the long shaft mixers, our Evo Plus with only 7.5 power consumption with 10 amperes. It's from the side entry mixers, the efficiency mixers are on the world. And yeah, we need around 5 to 6 mixers in a 32 diameter tank. And yeah, then you have a really low power consumption inside your digester.
Okay, so coming back to Palash, so no doubt that your company leads in the upgradation units in the market right now in India. As you rightly said that there are more than 120 installations already done. Can you throw some light about how your company has done technological innovations where the methane purity is more energy efficient and the losses are minimized? So what exactly have you done, or what brings a cutting edge when you compare with your competitors?
Thanks for the question, Srinivas. So we've been in the engineering field for, I don't know, we started in 1976. When I say we, I mean my father and the promoters of our companies. We then eventually started Atmos Power in 2010, looking at the green energy boom taking place in Germany, taking place in other European countries, and realizing that in the future there might be a similar wave happening in India. And I guess that bet turned out to be right, because when we installed the first upgradation system in 2011, no one really knew what upgradation even meant or what biogas upgradation was, at least in India. So it was an uphill challenge trying to educate customers on what upgradation is, what gas purification is, how it can enhance the efficiency of a biogas plant, how it can make it a much more viable option at a larger scale. So when we started in 2011, the first plant we installed was a single stage VPSA system, and we were having purity of about 92%. Methane losses was a term we did not know about, nor did our clients know about. Eventually, after setting up a few plants, we realized that the mass balance is really not matching, and there's a lot of methane that's coming out in the exhaust, going up to 15%, 20%. All that is revenue that is blowing away into the atmosphere, and it's a greenhouse gas. So we had to do something about it, coming from an engineering background. So we developed our second stage system, basically to capture the methane that gets exhausted from the first stage system, and it's recirculated back to the first stage. And using this system, we are now able to achieve methane purities of 98, 99% with a methane recovery of greater than 98%. Basically, that translates to a methane loss of less than 2%. Typically, we even achieve losses of 1%, but 2% is the higher range that we're achieving. And this is what we've finally been able to achieve. And that's why we're now working with a Swiss based company, a German based company, to replace their upgradation systems that have been installed in the past with a system and technology that we have developed in India. And we have a European patent for it now. In terms of keeping the costs low, a lot of the equipment that goes into our upgradation systems is manufactured by our multiple engineering companies. For example, we make the heat exchangers in-house, the vessels in-house, piping, vacuum pumps we've been making for the past 40 years. Blowers is made in collaboration. So it's a lot of things that is put into the package is made in-house, so we can control the costs, we can control the quality, and we can offer a package that we can stand by and guarantee for 15 or 20 years. So that's what helps us differentiate ourselves in the market.
So minimizing the methane slippages would be approximately around 1 to 2%, 3%, or less than that.
Yeah, so we basically, like I said earlier, there was nothing about methane slippage, no one cared about it, but now we are having sophisticated clients. We ourselves have developed this technology which helps us prevent the methane slippage. So we no longer offer a single state system, because with single state systems, unfortunately, losses will happen 10, 15, 20%. So with the second state system, it's basically just sucking out all the methane. So there's no way for the methane to escape, which allows us to reduce losses to 1, 2% now.
Okay, so coming back to Dr. Alphonse, uh, since past 2 days I've been visiting all the stalls, and I can say that your company, the technology you are providing itself is known for its innovation. So I'm sure that there are some cutting edges or cutting technology you have already done. Could you please explain about how your technology would benefit the biogas producers?
Yeah, first, as I explained in the beginning, there's a 40 years experience in the background. We started that biogas business, biogas upgrading, as I said, in the mid 80s. The mid 80s, biogas were mainly coming from landfills. Landfills are coming up with the extremely dirty gas, dirty in terms of CO2, H2S, a lot of VOCs, zeolites, and other stuff. So we developed technology at those days to cover the demands of the customer. The customer, since the old days, are the utility companies. Utility companies means in Germany and Europe, the gas grid owner, the natural gas companies which are running the gas grids, and the natural gas companies who are selling natural gas. So we were really driven by the demands of these customers, and because these customers are really requiring a very stringent gas quality. We're talking about gas qualities which sometimes you're even not able to make it with an upgrading plant. Even if you make 100% methane, it's even not the quality the gas customer is requiring. So, but we manage that. So, as I said, in the early days, we started that. We developed the PSA process in the 80s. It was a two-batch system we have had. It works fine. It was nice. But then the customer demand was coming with low power, low methane slip, as possible, no maintenance. This was again coming in the 90s because the customer, like the utilities companies, don't want to send out anyone to operate the plant and don't want to send anyone to service the plant. So we have to design a system which has minimized operating conditions in terms of manpower, and which allows them to operate the plant without any stop in a year. And practically, we have managed that. That was in the 90s. And since the 90s, we are providing this type of technologies with the so-called six-bed, multi-bed high-pressure PSA. Purities, whatever the customer wants is possible. We can adjust that purity within the plant. It's a dynamic process control. Methane slip, 1% is the standard meanwhile in Europe. You can go up much lower methane slip if you add on a second step. The advantage is we are doing this all in one step. It's an all integrated one-step PSA system. We are removing the moisture, we are moving the H2S, we are moving all the critical components. So at the end of the day, you're getting a gas which is extremely pure, which is ready to compress directly to the booster station or direct go into the grid. The advantage also is that the off gas is free of any odors, critical components, which is also then an extremely clean, let's say, CO2 stream. So that is something which we have developed about the around the technology based on the demands of the customers. And the customers are really still guiding the demands of the construction performance of the upgrading plant. And that is something I think we also try to bring to the Indian market, to really be a little bit concerned of customers' demand. And that is something which is coming from both sides, from the digester side because the digesters are operating independently from the biogas plant, upgrading plant, and also from the customer plant on the other side, bottling station. And the next step is what we are doing also in Europe, directly injecting to the grid. So we try to cope with the demands from both sides and make everything as much as possible optimized in terms of energy and methane losses.
So you cover the holistic picture, right, from digester as well as the end customer, which is a unique idea, and I'm sure that this is the right time for you to enter into India, and I'm sure that this conference will benefit to you. And Sunilji, when when we talk about the automation, so push towards automation is very high. So how automated or highly automated can we go, keeping the cost low and ensuring that there are some predictive maintenance can be looked into it? How you are handling when you're installing plants outside India, because you have already installed quite a number of plants outside India. In India, the things are completely different compared to the other countries. But how are you able to handle both the technologies in India and abroad?
Yeah, thank you. Yeah, recently we have been working on the real-time remote monitoring, and most of the plants we are getting the readings online. So even the plant is in Indonesia, Malaysia, or even in Africa. So we are able to get the readings to our head office, or where the customer wants. So that is one improvement we have done. So on the technological front, okay. And coming to the digester, the digester parameters are very crucial for the biogas plant. So we have been presently working on the real-time monitoring of the digester parameters, so that any variation in the digester parameters like a pH, the solids, the alkalinity, so such parameters, including the temperature, so such parameters can be monitored by our team, so as well as the client team on the site. So even the client team on the site forgets to monitor these things or take the corrective actions on time, so we can always alert them, we can always help them to monitor the things and correct the parameters which are going in the wrong path. So this is the present our working condition.
So yes, remote monitoring is a key, and I'm sure that uh, the coming days would be for automation, and every plant should include the remote monitoring system, so that the plants can be monitored remotely, and whatever preventive measures can be taken, it can be suggested. Along with when you have a remote monitoring system, the equipment suppliers can also be shared the same data, so that they can also support the plant. So overall, the maintenance time, I'm sure, will come down drastically as compared to the present scenario where everything people are dependent on on-site or project managers or operators. So, Florian, I have a different type of question, because when you talk about biogas, sustainability is a concern in biogas industry. So, can you throw some light about how your equipment manufacturing is reducing the environmental footprint?
Yes, we have different parts of that. The first part is that we produce the whole mixer, or better, the important things of the mixer in Germany. But the parts we can buy in India. We buy it in India. It's like the motor, the gearbox, the sealing plates, and for that we need not so much space inside the sea container for the mixer. We can send around 30 to 40 mixer in future to India directly to the customer. And yes, then the assembly will be in India. We rent a workshop in Hyderabad for our subsidiary. There we have one or two guys to assemble the mixer in this workshop. I think there we save a lot of money for the customer, and the footprint is much more better. Then we develop our mixer every time much more, because the energy efficiency in Europe, in India, I think it's the same. That we would like to produce gas and money, and not to put too much energy inside the digester. We would like to have the energy. Because of that, we use small engines with bigger propeller blades to to save the electricity. We have a really low power consumption with our mixer with a big plate. I told you for 10 minutes around. And yes, this is the next step. And yeah, and we develop new mixers with much more bigger propellers in future. That then we need not so much mixer inside the digester. Then we need only 3 or 4. Now we need 6 or 7 mixers. I think then we save a lot of energy consumption too.
Yeah, it's a very good idea about manufacturing, and I'm sure that the way biogas industry is developing in India, you will start manufacturing very soon in India, and the manufacturing cost as well as overall the equipment cost would be much lower, and this will obviously benefit the biogas industry and the biogas players. Thank you. And Palash, uh, upgradation units are becoming very critical when you talk about biogas plants. So, how can you handle different or diverse feedstocks which are being treated across the country? Because I have seen spent wash, press mud, cow manure, agricultural waste, and now everybody started talking about paddy straw and napier grass. So, how your systems are equipped to handle different purity of methane or change in the methane along with different hydrogen sulfide concentrations in your system?
Yeah, that's an interesting question because in our initial plans, we used to go by what the client was giving us as the raw biogas specification. They would tell us they have a certain amount of carbon dioxide, certain amount of moisture, certain amount of H2S, and we would design the system based on the feedback we are getting from the client. And what we started realizing is that oftentimes, due to unforeseen reasons, the raw gas would keep changing, and there would be no control on the raw gas specifications, which affected our system's performance because we had designed it based on the parameters shared by the clients. However, when the feedstock changes, the gas composition changes, and unfortunately, feedstock has to be changed because we don't have enforceable contracts in our country. So even if you have a raw material agreement with a supplier of feedstock for, let's say, 100 tons of X waste, tomorrow he might not be able to give it to you. So you will have to switch the feedstock, and when you switch the feedstock, the composition of the raw gas will change, and when that changes, it'll affect the purification system and everything downstream of the raw biogas. So considering all of these factors, we've started offering a completely integrated, I would like to say, turnkey purification system where even if the client says that they don't have a high amount of H2S, based on our experience of setting up 120 plants, the H2S will vary and it will certain times go above the limit that has been specified by the client. So we offer a turnkey solution in which even if your H2S you've set 10,000, but if it goes to 1,000. If it goes up to 10,000, our system will still be able to handle it because it is a robust system which is designed to work with differentiations in feedstock, differentiations in gas compositions. So we remove the H2S, whatever the quantity is. It's only the OPEX that gets affected because more amount of NaOH or whatever medium we're using to absorb the H2S increases. But the plant itself can manage any variations, and biogas is a relatively simpler medium to work with. We've also worked with India's first landfill gas upgradation system, which is based in Hyderabad. We did it for Ramki engineers. So in landfill gas, the impurities are significantly higher, such as the VOCs, the siloxanes, and many other, sometimes ammonia and stuff like that. So if we could deal with that system and make a robust system that can work with those impurities, making systems for biogas is relatively simpler for us now. And based on that, any feedstock, any variations, our system will adapt very easily and it can give you the required purity in the product gas.
Okay, so handling the landfill gas itself is very, I can say, difficult. And this is the only project in the country, I believe, that is working on landfill gas because it's really difficult to predict the methane or the siloxanes, which I'm sure that Dr. Alfonso will also agree to it. And Dr. Alfonso, when we talk about upgradation, it's like the innovations the other companies are making, or when I see from biogas developer or the installer point of view, he is interested in the operational cost. How well your plants or your innovations help the biogas operators to reduce the operational cost, at the same time it have a long term operational efficiency?
Yeah. as I said, well, we are trained by our customers since 40 years, and we have a lot of experience with a lot of different customers, a lot of different feedstock, and a lot of different requirements from the customer side. The plant itself, the system itself is, as I said, designed that you have minimum, really minimum demand of operator. Practically, it's for a normal operation, you don't anyone. It's equipped typically also with a remote control. So if you want, you can control this type of plants also completely remote. The costs as such are mainly then depending on, as my colleague already said, it's how big is the H2S demand content in the raw gas. Based on that, you have a different demand of activated carbon or washing media. That depends on the level of HDS. If you have a high level of HDS, it's more cost efficient to have a pre-step, means you have a bulk removal within scrubber, and then you're going directly into the PSA, and the final removal is inside the PSA. So that is the cost optimized setup of such a system. As I already told you, you have to do this together with the customer. But as I said, once you have experienced the different type of raw gases, different type of materials, different types of flow, different types of gas qualities coming in and going out, then based on that, all the requirements have gone into the design of such a system. So that is the system which, as I said, we are operating 10, 15 years, meanwhile now in Europe and also in US. And the cost as such is, besides the operating costs and maintenance costs, maintenance costs is what is it's coming back to the rotating machines. Rotating machines is a compressor that needs an oil change. Meanwhile, the compressors which we are designing also within the GPE gas processing company, they are so designed that the oil changes once half a year, maybe only once one a year. So that's also a question of which type of oil you're using, which type of machine you are designing. So besides that, there is no, let's say, frequent or regular change of any of the system itself. From the cost side, then in addition to that, HDS, as I said, is one of the most critical parts in terms of operating costs, because HDS level is high. Then if you use just activated carbon, the demand of activated carbon is extremely going high. So you have to find the right way to have the right cut, to have the right cut between scrubbing and activated carbon. So that is something you have to do together with the customer. So again, as I said, you have to talk with the customer, and based on the experience, the plant is designed to minimize really the operating cost.
So no doubt you have already done a lot by reducing the operational cost to an extent that the biogas plant owners will hardly have to worry about any operational expenses. And yes, a remote monitoring system not only for biogas but upgradation systems can be a game changer. I can say that many systems can be looked into it. So our next speaker, Mr. Marcelo, could you introduce yourself, because we have.
Hello, good afternoon, and forgive me for the delay. It's the first time I attend this, so it was quite an adventure to arrive from the booth to here. Now I understand in the WhatsApp chat why they were commenting. Sorry about that. Okay, my name is Marcello. I'm from Italy, and I'm the business developer for a French company whose name is Prodeval. You can Google it, prodeval.com. And it's one of the main players in Europe and North America for biogas upgrading unit. My background, I'm an environmental engineer, and since 2003, I'm working in biogas and bio CNG industry.
So, Marcelo, can you explain the members over here about how well your upgradation unit is placed when you talk about what innovations have your system brought to the technology?
Thank you for your question. And well, when it comes to biogas upgrading, it's we come in Europe after 15 years where the biogas was combined with the power generation. Then only recently, in the last maybe 5 to 8 years, the market went through biogas upgrading, linked to some geopolitical issues. We needed to decrease our dependency of importation for methane from other countries. And at the same time, European Union pushed a lot for reducing the greenhouse gas emissions. So everybody in the industry needed to find innovation and new technologies, and it's not rocket science. And at the end, we arrived to a very simple process, which is a kind of filtration of the gas. Basically, it's a three-stage membrane process that from the biogas can arrive to the bio-CNG. So what is the innovation? Most of the system before, back in the past, were quite simple. So you have one stage membrane, the biogas comes in, and the biogas goes out filtered. These membranes can separate the carbon dioxide from the methane. Basically, it's a filter, quite simple. The pressure is relatively low. We are at 12 bars. So then the idea was, okay, let's try, because you have one output, which is the CBG, no? And the second output is what we call it off gas. But in the off gas, there is still some methane that you lose. So the first concept we have to address is the methane slip, the loss of methane in the process, which is quite important. So the idea is, okay, then I add a second stage to increase the quality of biogas, biomethane. So biogas, stage number 1, stage number 2, and I have the biomethane with 97, 98% purity. This depends from the membrane characteristic. The off gas coming out of the second stage still has some methane. So the third stage will not have an impact on the quality of the biomethane. The quality depends from the two-stage. So whoever is selling two-stage process is still delivering biomethane or CBG at 97, 98% purity. This will not change. The third stage will change the methane slip. So how much biomethane or CBG I lose during the process. Now, if I ask anybody in the room, please, can you tell me 1% lost, how much money we lose? Just shoot a number.
You're talking about the life cycle
No,
analysis, or
I'm talking about if my system is losing 1% methane, how much money in 20 years I'm losing?
20 years?
Yes, I tell you. We discussed briefly yesterday about that. So a 10 tons project, 10 tons per day, if it loses 1% methane during the process, it's losing 5 crores. 5 crores in 20 years. So 2%, 10 crores, and so on. So imagine how important is financially the efficiency of the project compared to two-stage process or vacuum pressures with BPSA, where the sleep is much higher. So we believe that innovation, coming back to the original question, is we work on reducing the methane sleep. One last thing. In Germany, I don't know if there is any German here, the German regulation, hello, hi, wie geht's dir? So you know better. You know better. You guys want maximum 0.2% methane slip, 0.2 methane slip, not more than that. So we are already working on the fourth stage. So 1, 2, 3, the off gas goes to the fourth stage to meet the German parameters. So everything, when we sit in front of our customer, there is no like asking for discount or they do ask discount. But the first question is not how much you cost, but is how much is your methane slip? Otherwise, there is no discussion. I can talk
So,
more, but
Marcelo,
stop.
I can
Block
only
my
add.
hands and I will.
Yeah, I can only say that we are discussing about 1 to 3% loss, and I'm sure that when you are coming below 1%, you're already saving 15 crores for the life cycle in the life cycle. Yeah, 5 crore per percent, right? So it is 15 crores for 3% loss. So you're already saving 15 crores for every project in the life cycle analysis. So this is really good, and I'm sure that other upgradation units might also welcome him. And the bracket of 1 to 3% loss, so he might be leading the space right now, though the number of plants or the installations Atmos Power is leading. But yes, welcome to India. And Sunil, when I talk about, yes, we have already discussed about innovations, large scale plants, different feedstock. But what are the significant technology barriers you see when it comes to small and medium scale? Are you also getting inquiries or installing these small and medium scale, or only looking for large scale plants?
Yeah, we are into all segments of the biogas and bioscience field. We are into small scale, medium scale, and large scale also. And just to brief more about this, we are into actually the boot kind of projects. So that is our major strength. So coming back to the core question, so what are the barriers? Yeah, barriers I have seen with my experience. So this is normally the small scale biogas plants, they fall prey to the price. Please talk to the, my advice is please talk to at least 10 suppliers, 10 the technology providers before putting but the biogas plant. So don't look at the price in the initial stage. Then you will know to. So then you will know. So what are the offerings that technology provider is giving you? What are the options he is giving you? So the in initial stage, if you look at the price, you lose the larger picture of the biogas plant. You lose the larger efficiency of the biogas plant. The second thing is, so normally the small scale plants are built on the single feedstock. Please never. So always plan your biogas plant on the multi feedstocks. So because when you depend on the single feedstock, you don't know when the feedstock supplier is going to lift their hands, because now the more number of biogas plants coming up, so there is a growing demand for the feedstocks. So always plan your the biogas plant, the bioenergy plant based on the multi feedstocks. So this is my observations.
Okay, so in short, you have already explained about the difference between the plant cost and the project cost, and everybody needs to look into the BOQ or the bill of material rather than looking at the project cost, because project cost might be misleading. And Palash, as you continue to expand your leadership in Indian market, so what measures have you taken to reduce the capital cost as well as the operational cost so that it becomes viable for every biogas supplier to join hands with your company?
Thank you for the question. So when we started off, I said the first plant that we installed was in 2011. That was a 50 cubic meter per hour system. So if you go and see in Europe, they don't even consider a system that is smaller than 250 or 500 to make it viable. The smallest one that we've designed is a 20 cubic meter per hour system, which is extremely small system and is possibly the smallest system that you can make. And in terms of developing systems for small scale biogas plants, most of the biogas plants that will be set up in India and that will be viable will be small scale eventually. That's what we've realized in the past 15 years when we've seen large scale biogas plants set up. None of them have been operating at their full capacity because of feedstock issues, because of equipment issues, breakdowns, etc. And we did a brief calculation with the CGD providers such as Torrent Gas, Adani Power and stuff, and all of them say that the maximum you can sell from a gas station on average is 1 to 2 tons per day. And if you're making a plant of 10 tons per day or 15 tons per day or 20 tons per day, the best you can do is grid injection, because if you try to transport fuel to 20 gas stations and sell it and then take the inventory from there and try to manage it, it's an entire different business by itself. You could actually have a business case saying that I will buy the gas from your plant and sell it to these stations, and that would be a business model by itself because it's such a big challenge for people. So coming back to making small scale systems, the beauty of the VPSA system is that it operates at 0.7 bar gauge pressure compared to a typical PSA that might operate at 6 to 10 bar gauge pressure, or a membrane that might operate at 14 bar pressure. We operate at 0.7 bar gauge pressure, so the pressure requirement is significantly lower, which translates to a lower operating expense in terms of power requirement. The wear and tear is much lower, and because we operate at low pressure, we work with blowers, and blowers are relatively cheaper as compared to a high pressure compressor. So we can also offer a standby blower, which we have now started offering as a standard supply, so that whenever there's a breakdown in the blower which feeds gas to the system, there is no downtime, because the second blower will immediately come online and it'll start processing the gas. So because of the equipment cost that is lower in the purification system for VPSA, you can give a lot of standbys for the critical components, which ensures that you don't have any downtime. We have an example of the Indian Oil Tanking Limited company, where we installed a plant last October. and it's been running for 23, 24 hours on a continuous basis. So that's, I would say, our flagship plant, because we're not having any issues with the raw biogas. A lot of times what happens is that our plants run for 2 hours a day, 3 hours a day, and then shut down because of lack of raw biogas. But when you give them continuous raw biogas, it really gives them a chance to perform, and actually you can test the purity level. So we're getting about 98 to 99% CH4 purity, and we're limiting methane losses to 1 to 2% using a two-stage system. So my friend from ProDeval mentioned correctly that you need to have multiple stages if you are interested in methane recovery, which I believe every customer should be. So now we're also offering a two-stage recovery system for the smaller systems. So you can, even if it's a 2-ton plant or a 1-ton plant, the standard offer from us will be a two-stage system, because methane recovery is no longer an option, but it's a requirement because of the environmental concerns and because of the commercial impact.
So I'm sure that when you talk about technology, technology has already seen its days, and it's the time for innovations which you guys are bringing to the game. So Florian, my next question would be for you that equipment selection is a key. Okay, so when I see the European market where the plants or the feedstocks are limited compared to maize silage or corn silage, compared to the diverse feedstocks which are available in India, and different types of feedstock, municipal solid waste, you have napier grass, you have chicken litter, cow manure, how your equipment sizing or selection can be done, and how you're ensuring that these diverse needs meet your equipment.
Thank you for the question, but yeah, it's really important that you have the experience which components you must use in your digester. Yes, we as Amatec FTS, we have now the experience of over 30 years in the biogas market for mixing technology. I think we sell the first mixer in 1985. For a small biogas plant in Germany. Yeah, in Germany we have many different biogas plants, municipal waste plants, normal agriculture waste plants, and bigger industrial plants. And you must know which feedstock you have. Then you can choose your mixing system. What do you need inside your digester or post digester or end storage tanks? It depends on the feedstock, you know. Yeah, in the municipal waste plants, yeah, the substrate will be more aggressive than in an agricultural waste plant, because the pH value is much more lower. Then you need your stainless steel mixers, and from the side entry mixer or paddle mixer will be every time better than you use a submersible mixer, because the submersible mixer is every time the motor and the gearbox inside the digester. Then you have heating problems, you have problems with your gearboxes, then you must change it, you must open your roof, you must put it out. Yeah, with a side entry mixer, it's much more easier to make the service on the mixers. And yeah, the modular system, it's really important. Big propeller for the higher dry matter contents. I tell you before, yeah. Because of that, we must choose it. We have the experience in special tanks. We use CFD simulations for the tanks, but a CFD simulation is only a small view inside the digester, because you must work with your system, with your biogas plant. In Germany, in the past, they said the biogas builder said to the customers, "You need only 1 hour per day on the biogas plant." That's not correct. You must work with your biogas plant. Because of that, you must show inside your digester. You must. I tell my customer, you must play a little bit with your mixers. You must change the RPM. You must change the direction. Then you can handle every substrate, I think. Yes, now in India, it's the interesting substrate, the paddy straw and the napier grass. Yeah, I think in future, next year or something else, we have the municipal waste plants. We have in Germany 2. In India, we have sold around 2 or 3 projects with municipal waste. I think, yeah, ask us, and then we can choose how many mixer you need and which type of mixer you need. Yeah, we will help you.
So okay, when you talk about equipment selection, then CFD analysis for particularly agitators is a must, you mean to say?
No, I think CFD simulation is not a must. It's the experience from the mixing technology provider. The experience much more better than a CFD simulation. A CFD simulation is only theoretical information. I think you see only 4 or 5 minutes from a digester. You have no idea how the customer will feed the digester, what is the size of the fiber length. Yeah, the mixer is every time in the same direction. A CFD simulation, I don't know. Yeah, you can see it works, but only for 5 minutes.
So, Dr. Alfonso, I just want to add that as the biogas sector evolves, companies are talking about circular economy. So, how well you are managing the byproducts when it comes to upgradation units?
Yeah, first of all, that main target of the biogas upgrading plant is producing nice product, means nice product is methane and it's CNG. The advantage of the system is, and that is valid for most of the all upgrading system except the washing system. You're getting an off gas stream which is highly concentrated with CO2, and if you have removed all the HDS before you're going into the BOP, then also this off gas stream is without any HDS. This you can call it as a byproduct. And what you have to add an CO2 liquefaction plant. And then based on that, you can sell out also the CO2 to the market as liquefied CO2. Whether this is viable or not depends on the sales price of CO2 in India. I had a little bit doubt because CO2 prices here in India, industrial CO2, is not sold at that high price that it will, let's say, compensate the additional costs you're putting in to recover, liquefy, purify, ship out, store the liquid CO2. In Germany, in Europe, it's very popular. My colleague from Proval knows it. But the reason behind this, we get carbon credits, we get incentives for the CO2. It's sold as a byproduct because there's a lot of supports, governmental supports. It's sold as a green byproduct. Whether it works here in India or not, that depends on the market price and whether the government is willing to support also this additional byproducts as a co-product. Another byproduct you could produce is from the HDS removal system. If you have a high HDS removal, then with some several percent of HDS, yes, with a scrubbing system, you can get out a slurry, a high concentrated sulfur slurry, which you could sell to the market. But again, it's not purified sulfur, so you need a further processing plant to purify that off gas, the slurry to high pure sulfur. So that is practically the byproducts you can sell, let's say, in addition to methane from these type of plants.
Okay. So, coming back to Marcelo, I just wanted to understand that when you talk about Indian biogas industry, the different feedstocks will give you different percentage of methane. How well your technology will ensure that there are less methane slippages and higher efficiency, or high amount of end product?
Yes, also maybe he's the best guy to answer to this. But first of all, if we are here because all of us are interested in bioenergies, and the question sometimes I like to ask is why we should we should think about investing in CBG for basically two main reasons. One, to reduce the emissions of greenhouse gases, and by doing that, we have to make money out of that because nobody's going to invest only for environmental purpose unless they earn money. That's the reality. So do something good for environment, but by earning money. That's why the first question should not be, I understand, of course, but might not be how do we decrease the investment cost, but is how we maximize the profit and how we minimize the emission of the emission of greenhouse gases. So how do we do something even better for the environment, earning even more from this process? And the answer, according to me, is pretty simple, straightforward. It's economic and mathematics. So you have to decrease your main value is the CBG. If you throw it away, you don't earn from that. So you have to decrease the amount of CBG that you throw away by optimizing the system, decreasing the methane slip. And I don't believe this is linked, coming to your question, to the kind of feedstock. And by maximizing the life of the project. The more I run my project, the more I earn money. So if you do a business plan at 10 years, at 15 years, at 20 years, of course, the return of the investment change. And this goes a little bit in conflict with reducing the investment costs. So mainly I wouldn't ask how to reduce the cost. I would ask how to maximize the profit and extend the lifetime of the project. Regarding ProDeval, which is involved in the upgrading system, there is not a big difference for us which kind of feedstock. It can come from municipal solid waste, from manure, from neighbor grass, from paddy straw, and the final product is the gas, the biogas. And the characteristic of the biogas is pretty much known, and we can deal with every change in the process. So the membrane process is quite flexible towards the magnitude. So how big is the project? Being modular membrane, no? You know how they are done. That's pipes with membrane like spaghetti inside. So the more pipes you put, the bigger is the flux you get. So it's pretty modular, the concept. And so bigger is the project, more membranes, and we can adjust to that. And also smaller is the project, and we can adjust to that. I always like to say that biogas is the most democratic way to have a renewable energy, because wind is for big boys, and but from the small farmer to the big municipality to the big investor to the normal private guy, everybody can invest in biogas. And coming back to his answer before about the barriers, I fully agree. One barrier, and that's why multi-feedstock approach is correct, is the logistic. Big headache under evaluated here is the logistic of the process. And the second, I would like to add on that, the second barrier is also the delivery, so the off-taking, which is not so granted. That's why he was right before telling the headache about delivering in a virtual pipeline. And the third one didn't mention yet, unless before that the banks are not financing in project financing here. So it's more like corporate financing. So at the moment, the big boys have a benefit out of biogas, and the normal guys like us, we don't really benefit of that. Of course, things will change, will improve. Also, we will arrive in India to project financing. Project financing means that they are financing the project, not you. So they believe in the project, and the collateral is the project itself. At the moment, maybe some bank, I don't know if someone is here from the bank, but they tend to ask to go to a different way of financing. And this is against the definition I gave about being democratic source of renewable energy. Because a small farmer that has land and maybe some animals and control the feedstock should be financed very easy, because the real headache is the feedstock, not other issues.
So you have rightly touched the point about big, large, and mega projects. But given the scalability, when it comes to biogas, the sizing is the key issue. So how or what is the minimum size you can come up with for the Indian market? The upgradation unit, yes.
Biogas is democratic. We have, I'm sure you guys made project also for 200 cows. So it can go as small as, I don't know, 50, 100 kilowatts. Depends also how many kilowatt hours you can sell if it's electric. But for CBG, maybe it has to be a little bit bigger. I believe in ProDeval, the smallest can be around equivalent of 250 kilowatts. So maybe, yeah, that's, but it depends also on the price of CBG. If you sell CBG at 70 rupiah per kilo, maybe a 5 tons or a 2.5 tons per day can be already viable. If you don't forget that in India, you have the biggest support for the, you call it organic manure, which we call digestate, which we don't have in Europe. In Europe, maybe they pick it up for free. Maybe sometimes we sell with small money, but in India, you have a support on that, which is very bright. So considering the support you have on the solid digestate or organic manure, as you call it, I believe that also 2.5 tons per day TPD plant can be viable for biogas and biomethane. Where is the party? Let's go.
So thank you, Marcelo. And yes, we have already seen about the power of innovation and how it is helping the biogas industry. So yes, the floor is open for the questions if anybody has, because already we have crossed the time limit. So Just feel free to add at least 3 questions or 4 questions we can take. So any questions? Yes. So everybody is happy with your innovations, I guess.
Don't be shy because
Yes.
nice.
Shankar.
You talked about the recovery. First, whether these biogas plants are equipped with inlet mass flow meter and outlet flow meter. It's a question to all the biogas upgradation vendor.
The question
could you-
is when you, yeah, the question is for both of you, maybe.
Could you repeat it a little bit louder?
Sure.
Yeah.
I'll repeat it. When you are installing a biogas plant, do you provide mass flow or volume flow meter at the inlet and outlet?
I guess we do. Do you
Yeah,
guys do?
definitely, you have to measure everything. And I tell you, the more you measure, the more accurate and the more money you earn. I don't know you guys, but we have a chromatograph. So,
Was there a lie?
we use chromatograph, which is a little bit more expensive than normal system. But it,
both inlet and outlet?
sorry,
Do you use it
before and after, yes. Before, these guys have to give us you have the gas analyzer.
So
You don't. Okay.
no, Mr. Marcelo, this chromatograph, do you use the same one for inlet and outlet?
Yes.
Okay.
Because I want to know also the volatile VOC, organic compounds,
Yeah.
which are damaging the membranes and the ammonia, all the post H2S, as he said. We want to make sure that the, the scrubber is working properly before hitting the membrane. So before and after, and also between the stage, between 1 and 2, 2 and 3, I want to know everything because by knowing that you control.
You have got only one chromatograph
Yes, one.
and measure that.
Yeah.
What about you, sir?
So there is one flow meter to measure the raw biogas that we're getting so that we know what we have to process. And there is an outlet flow meter to let the client know what we're giving out. So example, our IOTL plant that I mentioned earlier, there is a raw biogas flow meter which tells us X amount of raw gas that we're getting, and the flow meter at the outlet tells us the flow that we're giving out. Very nicely, there is also a gas analyzer at the exhaust of the system which measures exactly the composition of the gas that is being exhausted. A lot of times you can juggle with the mass balance and say I'm having recoveries, but the best test is take a handheld analyzer, cost 2-3 lakhs, go near the exhaust of your system, put it there and measure the composition of the gas that is coming out and the CH4 slip that is actually coming out of the system. And you can also keep a flow meter there, so it'll give you exactly what's going in and going out.
The question is that 2-3 lakhs worth of analyzer.
You're not being clear, sir. Can you
I'm
put
sorry.
in? Yeah.
I'm sorry. 2-3 lakhs worth of analyzer will not give you all the gases properly.
It's a handheld German analyzer which you can particularly tweak for the gas profile that you want to do. The stationary analyzers have multiple points and those cost about 25 to 30 lakhs.
It's okay.
How much is in dollar? That again?
You can say maybe $35,000.
That's not a chromatograph.
No, that's not
No,
the comment. That's a
chromatograph will be
NDIR.
even more
yeah,
expensive.
Yeah,
Yeah, it's okay, but also the way they do it is perfect and very good that they measure the composition on the exhaust. I
That's
was
very good.
somewhere, I don't tell where, and I wanted to know because I'm always thinking about methane slip. And I asked the owner, like, can I see the methane slip? Oh no, we don't know because we don't measure.
Yeah.
Okay, so
No, so
Good.
that's when you work with
Good. Thank you. Thank you.
oil and gas company, you're working basically with the owner of a refinery, so they know how to check you. So that's
Yes, Mancha, you
I
can.
have one question to the upgradation companies. For a typical 8-ton, let's say, bio-CNG plant capacity, incidentally, you're also generating about 6 tons of CO2.
2.2. 1 to 2.2.
Okay. So, in terms of kgs, okay, if you look at it, then is there any way you're working on utilizing that CO2 by any chance?
So we've been in this field for since 2010 now, and we've quoted about at least 500 times for a CO2 recovery system. But unfortunately, because of the rate of CO2 that you're getting in the market, it doesn't turn out to be viable for the client. So they don't end up going for it. But for large scale plants, we see that happening, and we have the technology to recover the CO2, liquefy it, and then you can sell it as food grade CO2, or you can sell it through greenhouses. So that is possible.
Yeah, so it's
Okay.
10
All right.
tons project, CBG, 22 tons CO2. And I agree with him with the answer. So if there is a market, I think above, everything above 60, $70 per ton should make sense for industrial grade. Food grade, the problem is that, for food grade, the real problem, that if you want to sell to Coca-Cola, whatever like that, only the analyzer and the tank, all in all, is sorry, I talk dollars, maybe $500,000 for the egg analyzer. You know what is like? Because Coca-Cola, before buying, they want to know and prove exactly if you are 99.99998. To do the job, we need to spend like $350,000 only for that, plus the storage, which also they have very, so food grade is very expensive. But I believe that, as you said, on big scale, there might be a market. In the project we are building in Uttar Pradesh, we have CO2, liquid CO2, food grade.
Yeah, thank you. I guess the next session is about to start, and thank you for your valuable insights to all the speakers. And let's continue pushing the boundaries of innovation and ensure that the biogas in India has a sustainable future.
Thank you so much to all the distinguished speakers for your valuable contribution. So now I would like to request Mr. Srinivas Kasula to kindly do the ceremony, the felicitation ceremony. So first, can we have Mr. Palash Navroz Sarabor? Can we have the mementos, please? Mr. Kasula, kindly present the memento to Mr. Palash. Mr. Marcello Barbato, please. Next, can we have Mr. Florian? Big round of applause, ladies and gentlemen. Now, can we have Dr. Alphonse? Mr. Sunil, please. Now, to present the memento to Mr. Srinivas Kasula, may I kindly call upon Dr. A.R. Shukla, President, Indian Biogas Association, once again. Dr. Shukla, please come on the stage. Thank you so much, Mr. Kasula, for your wonderful contribution and for moderating the session as well. It was indeed a knowledgeable session, which all of us enjoyed. Thank you so much to all our distinguished panelists. You may now take your seats. But just before a group photograph, Dr. Shukla, please do the honors. Yeah. A group photograph, please. Yes.